So, Jim, we've talked about this topic before in our previous podcast, but let us do a kind of a more in-depth view of your ideas, your theories, I guess. Uh, but before, I think many people don't know much about you, at least me. So maybe you can tell us a bit more about your background, like maybe your training or general interest, things like that.
Okay, well, yeah, obviously I do have a mainstream physics and astronomy background. And okay, I'm already joking. I don't like talking about myself. Yeah, recently interested in applying like that the model that Don Scott has of our solar system being on a current filament like that, and all the dynamics that can be explained that way, and with the idea of putting that into the bigger picture, how we spiral through the solar system. I mean, how we spiral through the galaxy, basically.
Okay, well, so let's talk then a bit about this model. So as I understand, you basically use Don Scott's model of Birkeland currents. So maybe tell us a bit more about what the model itself kind of represents, what should be observed according to this model.
Right. Both Don Scott and Michael Claridge started the picture right with the sun traveling more or less along the center of a filament and planets spiraling around them, so that from the direction that they're from the North Pole, they would be spiraling counterclockwise and they'd be heading towards the North Pole. That picture is right, but they didn't get into all the details that we should find, like how you explain eccentricity versus inclination, like why Pluto's orbit is inclined the way it is, and other dynamics, the solar cycle, the rotation and tilts of planets, all that has to be matched. If the model's right, then we're going to have to eventually explain all that, and that's what I was trying to do.
Yeah, I mean, what I meant was kind of what kind of properties do this current should have according to Don Scott. And as I understand, you agree with this model more or less, right?
Right.
For the layman's, maybe what is it? What is a Birkeland current for some of the viewers who might not be familiar?
Yeah, because this is quite a novel concept, in my opinion. So it might be useful to sort of describe the basic properties of this current.
Yeah, the most bizarre one, the counterintuitive one, is that instead of having a magnetic field wrapped around a current like the magnetic field around a wire, you get a constantly changing magnetic field direction from axial, like along the current at the center, and then it starts spiraling around, but then the magnetic field completely twists. It completely spirals around as you move outward, and that's really the key. That feature is what's going to explain a lot of dynamics, and most importantly, it explains why the magnetic fields, why we don't see magnetic fields from current filaments in space. That's the starting point that why we need that model in the electric universe.
Yeah, so as I understand it, kind of the most prominent feature of this current is that it's basically organized in these concentric cylinders, right? With a counter-directed magnetic field. And that's why we cannot detect, for example, this field through Faraday rotation readings, right? Because
right.
Can you tell a bit more about that?
Yeah, with Faraday rotation, the most important thing is that you need a consistent magnetic field pointed towards you or away from you along any sight line. But if it reverses direction, then it cancels. So in Don's model, because the magnetic field keeps rotating in direction, any sight line that you choose through one of those filaments, if you get a component of the magnetic field towards you, you just look a little farther into the filament and it'll be away from you, and so on. And you can, that happens on every sight line except exactly down the filament axis. That's the only place you'd see coherent magnetic field directions.
I think the most fascinating thing is that, well, Don Scott's model actually follows from kind of direct solution of Maxwell's equations, right? So this is the way that plasma kind of normally, naturally tends to organize itself in space. And some of the people, for example, Chris Reeve and Juan, they've noted that one of the most probably important features of such currents is that they don't emit any synchrotron radiation, right? Because the current is always parallel to the magnetic field vector, which means that the charged particles are not accelerated by the current, by the magnetic field, as for example in synchrotrons, where you have particle rotating around. So that makes them even harder to detect,
right?
As far as I understand.
And there's another issue, because obviously there's always going to be exceptions to minimum energy flow. Like in our solar system, we've got charge flowing everywhere. But since the magnetic field changes direction too, you don't even get like cyclotron radiation. All the models that you start out with in physics, where you talk about a charged particle circling in a magnetic field, in the simple textbook case, the background magnetic field is always parallel inside that radius where the particle is spiraling. But in a Birkeland current, there is never a radius that you could do that the magnetic field is always twisting. So to the extent that the magnetic field is relatively parallel, the model works. And so what it really does is it should suppress all but the highest energies of radiation. But it gives you a warped perspective, even to the extent that we can see the magnetic fields. So basically, that's a whole nother step that has to be taken in that Bessel function model, is you have to ask yourself what happens to, how would a charged particle spiral in that field? And it leads to some really counterintuitive results. Like one thing is, Don Scott showed that in his model, there's a radial electric field. So you might think a charged particle can go streaming out, which that radial electric field, by the way, explains why the sun has a current sheet. But then what should happen is, if that magnetic field is twisting as that charged particle goes out, it will spiral, but it'll spiral around that radial direction. In other words, it's not spiraling around the background magnetic field as in the classical model, but it's still spiraled. So it leads you to even the wrong idea of what the magnetic axis is if you're using the spiraling of the particle and the energy. It gives you the wrong axis.
Okay, so basically, if we're trying to detect something like that around us, like around the solar system or in our immediate interstellar neighborhood, basically, since we cannot detect directly these magnetic fields because they are hidden with these concentric layers of counter-directed magnetic field, as I understand, we should look at the motions of objects, right? Such as stars, for example, and try to understand how they fit into this model. Is that correct?
Right. That's where you get the idea of matching star motions to filamentary gas clouds and magnetic fields. And that goes back to that original puzzle, is the mainstream does see that gas clouds are aligned along the background magnetic field. They just don't see a magnetic field wrapped around by the right-hand rule. And that's why they say those are not current filaments. But that's where that Bessel function model, again, comes in. It tells you that we won't have a consistent magnetic field wrapped around in either direction. So that, because that cancels out, it keeps changing directions. It cancels in the Faraday rotation. But the background magnetic field, since it's always the same across the whole filament and outside the filament, we'll still see that. And that's really the mainstream objection as far as magnetic fields. It's not that we're not seeing a magnetic field. It's that we're seeing a magnetic field that seems to be the wrong direction for the electric model. But that's what Don's model solves. We don't see magnetic fields wrapped around like the field around a wire, around even things that clearly look like a Birkeland current, like the double helix nebula. There's no strong signature of a magnetic field wrapped around it. We see a magnetic field along it, and that's what you would get in Don's model. So that's why we really need it.
Okay, and do you think that, I mean, already one such current is a very complicated object, I would say, very complex, but what do you think about this double helix nebula and similar objects? Are they like two of those Birkeland currents wrapped around each other, or they are part of one single current?
Well, the whole idea is scalable in that and you can see this like in the engraved hourglass nebula. It's like probably the best picture of it, where if you have a large scale current filament, that the magnetic field of that then becomes the background magnetic field for smaller currents, which flow along those magnetic field lines. So we see that on all scales. Like as an example, you've got the idea from Wall already made the argument that current flows along the arms of a spiral galaxy. And sure enough, we see like at maybe at one radius from the spiral arm, an axial flow of stars along the spiral arm. That's what we should have. And then at another radius from a spiral arm, you might have a helical flow, like a flow of stars right down through the galactic plane. And we see that. That's where I'd put the local chimney in, actually, is at that point. But basically, you can follow it all the way down. That on any scale, the field of that current becomes the background magnetic field for smaller scale field aligned currents, and then so on and so on.
Yeah, and by the way, what do you think about galaxies? Are they like some like stable plasmoid type configurations of these currents, or how do they fit into this model? I mean, spiral galaxies, obviously.
Yeah, that I haven't been focused enough on that scale. I've been working from the scale of like the local chimney to the next scale, that like the local interstellar cloud down to the solar system scale. That's really like 3 orders of magnitude. And see that there still is an issue to be addressed on the larger scale, in that there is a propagation time that, if you accept that there's a light speed propagation time, that's going to do things to the dynamic that we don't have to worry about as much on the solar system scale.
Yeah, that's a good point. You know that there was a point in the EU community that even gravity, I mean, even like in Newtonian dynamics, the solar system is chaotic, that was already shown in like late 19th century. But if you have a finite speed of, I mean, the gravitational force, right? Then it would become even more chaotic, I would guess, because I mean it takes like 4 hours for example, for a gravitational perturbation from the sun to reach Neptune, and 4 more hours back. So I would expect it to become even more chaotic in this sense. So yeah, that's a good point. I mean, maybe actually galaxies are created because of some sort of lag effect, that kind of introduces some sort of feedback, or I don't know.
Right.
But yeah, okay. So if we are talking about smaller scales, right? So that's like maybe 1,000 light years or so, if I understand correctly. Uh, what are the other pieces of evidence that you can name for the hypothesis, I guess, that we're inside some system of those Birkeland currents?
Well, if you start at the scale of the local chimney, there's a whole bunch of features on that scale that become apparent. Like you have actual flow of stars along the center, a stream of stars coming down the central axis. You have a ring of stars rotating around the pinch point. You have the dense wall of cold gas and dust out at the edge of the local chimney. And let's see. Yeah, that's a picture of the local interstellar cloud. That's a smaller scale one yet than the local chimney one.
Okay.
But
Let me get that one.
What again are the features you think are the most would be the most prominent example of evidence for Birkeland current?
well, the hourglass shape already. The stream of stars down the center, a ring of stars rotating around right where we would put a plasma torus in a pinch. Then they see gas blowing out. I mean, in the mainstream model, what happens is that maybe supernova events in there blast out gas from both ends of these, but they do see a flow of out at the ends of these chimneys. And then we see all the Pleiades cluster itself is somewhere down towards that pinch, all these hot blue stars. And that's another sign of current flow. By the way, that ring of stars around where we'd have the torus, those are hot blue stars, and there's a lot of hot blue stars down in that stream in the center. But the Pleiades cluster itself is a lot of hot blue stars. And then the parallax distance problem to the Pleiades can be explained if there's bending of the difference between the direct and relative parallax can be explained by the bending of light in that direction. And clearly there's not enough gravitational mass to do that. But if plasma bends light, then that's where that would be the way to spot the plasma density.
Can you explain the difference between these two types of parallaxes that you mentioned?
Well, the direct parallax, basically what you do is you get a bead on an object from Earth or from a satellite orbiting Earth, and then you wait 6 months to go halfway around the orbit, and we use that as a baseline, and then you take another bead on the object, and it's basically trigonometry. It's not quite as simple as that, but you're basically doing trigonometry to estimate the distances. But with relative parallax, what you're doing is you're doing kind of the same thing. You're looking at the star, but what objects are behind that star, distant objects, and then you wait again 6 months and look at the object you're observing and see what background stars are behind it, and then measure the angular distance between those, basically. And you see how the foreground object that you're looking at moves compared to the background stars. But in that case, if light is bent around the object you're looking at, then the separation of those background stars isn't actually right. The star that's directly behind it, there's no light bending then. You're looking at it basically on a straight path. But the objects you're looking at off to the side of that are the ones, their light path is bent, so they're not where they appear to be. And that's going to mess up the angular parallax measurements. And you don't need a lot of light bending. Once you realize how insanely small those parallax angles are, if you're doing a triangle where the Earth's orbit is your baseline, and you're looking at how many light years away those stars are, you can see how crucial a straight line path of light would be if your distances measurements are going to be right. So you don't need a lot of light bending even to really throw that off. And again, you would think the mainstream would be looking for that, but they know that there's not enough gravity in that area to do that. Like with the sun, we only see light bending right near the solar surface. And that was Edward Dowdey's argument why it's not really bending of light the way Einstein would explain, but it's just the bending of light by these plasma double layers. But you see that that's where the issue is. And then the mainstream, of course, massage that away. They always tell you the problem's solved. If you look at later articles, they'll say the problem was solved, but really what they did is either more parallax by the method that they chose, or else they fit it in with other theories of like stellar brightness and all that. But it really isn't solved, you know, not correctly anyhow.
So as I understand it, kind of the crucial discrepancy between this model and the kind of mainstream gravitational model in terms of observations is that what mainstream calls the local chimney, they consider it being basically a hollow cavity, whereas
Right.
the Birkeland current model says that, well, it's not hollow, it's filled with plasma that actually carries a strong electric current. It's just that it's invisible because it's in dark mode, right?
Right. And that's where that single structure, that's where all the questions should be for the EU community. Like, you know that can't be hollow. The mainstream is saying it's very sparse, even compared to the relatively sparse atmosphere outside of that. So the question for the EU community is, why don't we see that? Why don't we see the magnetic fields of current flow through there? And Don Scott's model answers that. But then why don't we see it in any other way? And that's where you realize just how much in a minimum energy configuration current filament, all the charge disappears in almost every way that you can look for it. You don't see recombination between electrons and ions. You don't even see interactions between two different ions that might rob an electron from another one. You won't see that if ions are sorted into by Markland convection into the correct shells, and they're all moving together. They're not spiraling around the magnetic field, giving off radiation. Basically, it looks like nothing. It looks like almost a complete vacuum, where we should know the opposite is true. Just by that shape, if you want to explain it as a pinch in a current filament, you know that the plasma density has to be higher there than anywhere else, not just inside that tube, but especially right down in that pinch. So the fact that they're seeing that as a hollow bubble, you have to explain then all the reasons that we don't see the charge there. And like I say, the only hints that we have is that we've got bending of light there that can't be explained otherwise, and those hot blue stars, which in the EU model, that should be a lot of current flow then. But if you have a cluster of, like the Pleiades, fast spinning hot blue stars, that's a sign there's current. So there better be plasma feeding that if the EU model is right.
Okay, you've also mentioned Markland convection. That is basically, as I understand it, the sorting of the elements according to their basically electric charge, right? Or ionization potential, maybe. So, is there an observable evidence for that? Like maybe we see some discrepancies in elementary composition of stars in this structure that might prove that there's something, like Markland convection happening.
Well, yeah, that's easiest to see in the next scale down, like with the local interstellar cloud and clouds on that scale. The mainstream does see it, they just don't say Markland convection because that implies electric currents. But what they see is ionization gradients that vary with depth into the clouds. And they have trouble explaining that in the mainstream model. But they do see what we expect to see is different ionization states as we go deeper into the cloud from the surface. So they see filamentary clouds with an ionization gradient, and that's what we need. They just don't call it Markland convection. But that's another idea that has to be also retreated with that. If you look at models in the EU community for Markland convection, they still go back to that original model of a current, like right there, that's not a Bessel function model that they're using. So Markland convection actually works a little differently in that you can even get shells of material with Markland convection by within the shells even. That's effectively what would happen. In other words, even steeper ionization gradients than you would expect in the other model, which fits mainstream observations, by the way. So yeah,
Okay.
I'm a big fan of Don Scott's model. Really, it's the only way to salvage the.
Yeah, and the funny thing is that I mean, as far as I understand, nobody did what he did before. Whereas, as far as I see it, it was not that complex. Just basically put in Maxwell's equations for plasma and
That's why
solve them.
Don Scott did say, Lundquist came up with that idea first. He discovered it later, but that's how, a good idea you will come up with again. What Don did, though, is he took it further. Like Lundquist really did say that that's what should happen, basically. But Don Scott went further in that he started providing evidence that the counter rotation, he started looking into the effects that it should have. And Don did a good job of showing evidence for counter rotation on all kinds of scales, planetary poles to, just, he took that point to where I think it's pretty well, accepted in the EU community. And all I was trying to do is take all the other predictions that should have, and that's where you start seeing all that show up on the planetary scale. And again, the key on the solar system scale is that, and this is probably more a reminder for the EU community than the mainstream community, obviously, is going to ignore the whole electrical side of it. But we have to remember to keep in mind the gravitational part, that planets and comets do obey those inverse square laws and Kepler's laws, and those are pretty much gravity only. You're not going to get that from the Bessel function. So the correct solution to solar system dynamics is use gravity and magnetism, fit the gravitational orbits into minimum energy configuration orbits, and that will give you the solution to all these weird quirks, like the inclination versus eccentricity relationship.
I like that idea that you've put out recently, that like if I understood it correctly, like the electromagnetism sets like the set of possible configurations, let's say, whereas gravity acts as a, additional set of restrictions, so to speak, where, the bodies are aligned that way or another depending on gravity, but they're at the same time following this larger scale alignment, which is dictated by electromagnetism, right?
Right. See, that's the key to understanding why we got stuck with a gravity-only model as long as we did. If it's true that solar system objects are pretty close, at least, to being in a minimum energy configuration, then there are no magnetic forces on them. And it is gravity. It only becomes apparent when we deviate from those gravitational only orbits. That's where you get the problem. But as long as things are in a minimum energy configuration, it appears that they're in gravity only orbits because there's no magnetic force on them at that time. So that's oh, go ahead.
So do you think that, for example, cometary activity might be one of the cases of such misalignment, so to speak?
Right, exactly. You shouldn't have, if assuming that objects are traveling along a minimum energy configuration, following the magnetic field lines exactly, if they start to deviate from that, they should start spiraling around. And you know what happens when charge spirals around a magnetic field? You should start radiating. I mean, and that would be the reason then that objects would tend to go back to those minimum energy configuration orbits.
But we don't really see we see some changes in cometary orbits, but we don't see like any dramatic changes. I don't think so.
Right, which is why, let's see, we can throw the electric forces out right away. And we explain that by things being relatively shielded from each other. But you know that, for example, with all the electric activity that a comet shows, it doesn't really deviate much from the nice gravity-only elliptical orbits. That's why we know that there can't be a significant electrostatic force in play. It has to be gravity as something different. Otherwise, as a comet charges and discharges, as it becomes, you would see that in the orbit for sure. So there can't be an electrical component. So you're stuck with gravity and then magnetism. Now the thing that'll happen though in Don's model, again, if you're moving out radially, you don't get the same kind of twist you would with a consistent magnetic field wrapped around the solar system. So that, in other words, as something is moving radially away from the sun, it might spiral, but it won't curve off in one direction because of the magnetic field. Because the magnetic field itself is twisting, so the effect, in other words, will even cancel out as an object moves radially outward.
Okay, well, let us again jump like a level above in terms of scale. I just wanted to ask you about the other evidence for a Birkeland current in this local chimney or local interstellar cloud. In particular, I know there's kind of a discrepancy in measurements of Arcturus temperature. You've sent a very good paper about that to me some time ago. And there's also a problem with Sirius, as far as I'm aware, because, for example, the ancient astronomers, again, this is my knowledge, I'm not 100% sure about this, they've said that Sirius was a red star sometime before, which kind of means that it should have been colder, not a very long ago, maybe several thousands of years. So could this be an evidence of these stars traveling like transverse to the axis of a current, so that they, they fall into different areas with different current strengths or something like that?
Yeah, right. I'd even put, I see evidence of a pinch. It's maybe a little weak. Maybe I'm seeing what I want to see, but I view that as a pinch, pretty much where Sirius is now. Like it might have just come to that point and got the current flow. But yes, the records are really clear that it was a red star, and the same records that we trust for all these other observations. All of a sudden, we want to throw out that detail, like they messed up on that. And it's interesting that Sirius is more or less following us. It's actually gaining on us a little bit if you trust the radial velocities. It's where supposedly the sun is moving around 220 kilometers per second around the galaxy. Sirius is moving towards us with some small, maybe 8 kilometers per second. I forget the exact number on that, but it's mostly closing on us, but also moving across the sky. And that's where the work of the Sirius Research Institute, that should have been, everyone in the EU community really has to be aware of that. And what they found is that
You mean the Binary Research Institute?
Well, the Sirius Research Institute, now the Binary Research Institute, posts their work. But what the Sirius Research Institute did is they realized that the motion of Sirius across the sky always kept it in sync with precession. And they were there was an attempt to make that match like a gravity-only orbit, like as if maybe we're orbiting Sirius, but that doesn't work. But what does work is if Sirius is spiraling along the same axis, in other words, if it's traveling in the same filament or the same pair of filaments as we are traveling in, it will curve around in the sky at the same rate that our whole solar system precesses. And that's where also we should be aware of the work by, that's where the Binary Research Institute came in. He realized, Walter Crutton didn't realize that the whole solar system precesses. It's not just Earth precessing relative to the sun. And he points out all kinds of arguments with that mainstream model. But again, that's where you really should, even in the EU community, if you don't know what to make of that, you really should know that there has to be some component, at least, of precession that's not gravity only. And once you see, though, that where Sirius fits in, you realize that the precessional axis is really the axis of that whole filament. And you even get that from the picture that Don Scott and Michael Claridge have of the solar system traveling along a filament, kind of face on. That picture is correct, but you have to get to where there are two filaments twisting around each other. And that's where, like Eugene, what you have already found is that the solar apex does not match the background magnetic field. And if our solar system was traveling alone on a field-aligned current filament, face on, then what should happen is the background magnetic field should be the same as the apex direction, which would be the same as the north ecliptic pole, which should also be the sight line to any stars traveling along the filament ahead of us. And that should even be the spin axis for those stars. It would be really obvious if that was what's going on, but none of that matches observations. But now, if you think of stars spiraling around on filaments, that's where you can match the motion of Sirius matches that. It matches a star spiraling around at the same rate that we are. And the quirk with Vega is a star out ahead of us, but it's not directly ahead of us. It's a few degrees off the solar apex direction. and its spin axis, as close as we can measure, is a few degrees away from us. That's what you would expect if current filaments curve through space, not, if they were on a straight line, there would be correlations to everything instead of that slight mismatch because of that.
Yeah, okay. That's pretty fascinating, actually. You returning to the nearby stars. I already mentioned this problem with temperature of Arcturus. You said once that the solar system seems to move in a circle around Arcturus, with maybe some other stars, with a period of like 432,000 years or so. Can
Right.
you speak
Well, that's
about
where
this a bit
you
more?
have to get into, as a starting point, and I always cringe when I mention this, but in the Edgar Casey stuff material, he said that we're going around Arcturus and then together around the Pleiades. Like we go around Arcturus, around the Pleiades. And anyone with a mainstream background knows that there's no way that there's enough mass in the star Arcturus to keep us bound to it. Plus, there's more massive stars nearby, and so on. But then that's where all these quirks, if you're willing to look into it, the thing that should jump out at you right away is that Arcturus is one of the fastest moving stars across the sky, but almost all that motion is at a right angle to us. It's moving across the sky at something like 122 kilometers per second, but only 5 kilometers per second towards us. Now that is what you would see in an orbit, right? Even in a fairly circular orbit. So that was the first thing that caught my eye. And then when I looked at other stars, like I got beads on using astronomy software, you could go to Arcturus and measure the distance to other stars. And that's where you see that the stars ahead of us and the star behind us all seem to stay equidistant. It's like we're all in a ring. The stars that we seem to be traveling with are in an equidistant ring from Arcturus. And that was even more bizarre to me. But again, I know that there's not enough mass to explain that. But then when you realize that this is basically where I was when I was coming into EU in the beginning, I thought, without mass, it can't be mass. Sirius is way closer than Arcturus. It's like a quarter of the distance away. It's more massive than Arcturus. How could Arcturus affect us in a gravity-only universe and not Sirius? But then that high proper motion, I thought, wow, that's interesting. Here's a star coming down through the galactic plane. We know that our stream of stars is traveling more or less in the galaxy. The mainstream ideas were bobbing up through the galaxy. We kind of bob up and down as we orbit the galaxy. But the Arcturus stream is coming right down through the galactic plane. And I thought, where that would matter, this high relative motion, that's where magnetism comes in, right? If you have two objects not moving relative to each other by any great amount, they shouldn't affect each other magnetically. But when one stream is coming across at a right angle, that's where magnetism fits in. And that's where I was before I came to EU. I still had this really crude idea of stars basically like being charged particles and then magnetic fields. I didn't know anything about Birkeland currents or that stars were strung on Birkeland currents or anything like that. But I already had this idea that we could explain some of these dynamics if stars were charged. And then I wanted to see if anyone ever thought of that idea before. And well, you see where the rest of the path went from there.
Yeah, okay. So I've been gathering some questions before this conversation, and Ido mentioned that this 432-year cycle of us like seemingly orbiting Arcturus, could it be related to ancient concepts of Kali Yugas or other cycles like that, or Aztec mathematics?
Well, yeah, that's what's interesting. Like if you look at the first thing you do, if you look at the double helix nebula and you get mainstream estimates of that, they say that the one twist of that is 10,000 years. And if you notice, our precessional cycle is the same order of magnitude, around 26,000 years. You can then get a picture of how our local cloud is spiraling around in what our, and that motion is what causes our precessional cycle. But according to the Yuga cycle idea is that, and this comes more from Yukteswar and tried to make sense of the Indian data on that. But the whole idea is that our precessional cycle is caused by outside forces and our whole solar system precesses. And the story they would have is that this precessional cycle takes us into and out of magnetic fields on that scale, and that causes a rise and fall of even human consciousness. It affects the brain, it affects us. We get the rise and fall of civilizations. The whole idea, which is just crazy in the West. But the truth is, if we are spiraling in a Birkeland current that spirals in 24,000 years, or in the case of the double helix nebula, if you look at that spiraling in 10,000 years, you realize it does take whatever's in there towards and away from some source of magnetism. Why? Because if that double helix nebula is spiraling around a magnetic field, where does that magnetic field come from? It has to be off the side, right? There's no magnetic monopoles. The double helix nebula isn't spiraling around this infinitely straight magnetic field line. The source of that magnetism is that the magnetic field is curved around that, and then you do spiral towards and away from the source of that magnetic field. In the case of our local chimney, for example, if you're spiraling around that, you do go closer and farther to that center of magnetism. And in the Eastern text, the way it's put, it might sound a little more flaky and new agey, like seat of universal magnetism. But the effects, now that the electric biology people are starting to see, effects on, neuron growth with electric fields, or human intelligence, even evolutionary, maybe being linked to the background magnetic field, that all fits. This is more scientific data that fits with the idea of these cycles. Again, there's still an attempt to put it onto our Western view of continuous evolution, not rises and falls. Like I think we just don't want to think that if magnetic fields can affect human intelligence, it can only be for the increase. That's, I guess, the way we want to think about it. But all the ancient cultures, basically all around the world, had the same idea that we keep on the small scale. Like, we know that all astronomical cycles that we know about, the day-night cycle, it affects us insanely, and the seasonal cycles and solar cycle. But and we're finding more each day, like maybe radioactive decay rates varying with Earth's distance from the sun and so on. But obviously, in the West, once, sadly, we got rid of any history beyond 5,000 years ago because of the group that came to power, obviously we lost any longer cycles. And then modern science, even though they laugh at the very religious group that put those ideas in power, they still went back to, they still have that worldview. Basically this worldview where evolution is linear, and even the whole Big Bang is still that created in the beginning out of nothing. Whereas if you look at creation myths around the world, they were talking about creation out of the matter, out of this chaos, or out of by word, sound, voice, basically waves in that unstructured matter. That's where you get the structured matter. But it was never creation out of nothing, and there were creation cycles in almost all in all the legends. And each of the cultures kept different things. Like in the East, the Indians were big on the Yuga cycle, and then the longer term cycle, which matches the Pleiades orbit or our mass extinction cycle. If you want scientific terms for the Yuga cycle, it's the precessional cycle, and it does take us into and out of a magnetic field. And if you're looking for the longer term cycle that was important in the Indian culture, it's the same one as the mainstream's nemesis cycle or mass extinction cycle, but it matches exactly the motion of our solar system around the Pleiades. That would be the bigger cycle. So, but that's really what drives me more than I focus on the details of how dynamics work in Birkeland currents, just to prove that we are moving along that way, because that is the key to understanding the bigger picture. If you think of gravity-only orbits, you're not going to get any. Very simply, if we are orbiting the galaxy, since we don't have a clear binary partner, there are no cycles other than maybe that 225 million year orbit around galactic center. That's what we're stuck with in the gravity-only model. There are no astronomical cycles that are explainable other than that orbit. Since we're not orbiting a cluster, we're not part of a binary twin. And that's where the Binary Research Institute, they realized all this precessional idea was wrong. The mainstream's ideas were wrong, but they tried to patch that into a gravity-only orbit, and they started looking for a gravity-only object around us in a 24,000 year orbit, and that's what's wrong. And you can see that if you look at the double helix nebula, they have that spiraling on the same time scale, but that's definitely not gravity doing that.
Yeah, I think this whole idea fits really well with the kind of a widespread EU narrative that, the stories about the gods and the myths are actually stories about what happened in the sky, right? But I mean, the Thunderbolts usually speak about, Velikovsky and stuff like it happened right here in the solar system. But maybe people actually had an experience of these larger scale, I don't know, time scales or objects or events that happen on maybe 10,000, 100,000 year periodicity. So yeah,
right.
I think this is
that caused a split that should never have happened in the beginning. Like groups like the Binary Research Institute, Sirius Research Institute, researchers that were into like ancient cycles of time and advanced civilizations at one time, they tend to go one route, and then all the catastrophists went a different way. Like our solar system was completely different in the recent past, and nothing was the same. And you can see that the two groups kind of ignored all the research by the others. And at first, it does seem like they're inconsistent models. Like either there's cycles or there's radical changes, but they're not inconsistent. Almost everything, in the simplest case of like a capacitor, you can have a charging and discharging. That's not uniformitarianism at all when there's a discharge. It's the same kind of logic, basically. And that's where, once you know how Bessel-Gaussian filaments work on all scales, especially like from the laser light scale, they talk about them as being healing and self-repairing and restoring themselves to the same spatial and temporal conditions. What's missing there is very simply that after a change in a Birkeland current, things can go back to exactly, even in phase, everything that they were before after it goes by some obstruction. And that's the key to matching how you would get planetary catastrophes where everything goes to heck, and then still have observations over time that would put things, the pole back where it was, orbits back at the distance that they were before. Again, in the gravity only model, there's no salvaging that. Like if you have a nice stable gravitational system and then you bump something into another orbit, it's gone. The original information is gone. But if you think of it more as we do on the atomic level, if you bump something from the way we talk about electron orbits, you can jump up to an orbit and then jump back. You don't jump back to a whole different orbit. You jump back to exactly where you were before. It's the same kind of logic, basically. That's more my personal belief. I believe that the planetary catastrophes were true. I mean, they're recorded. There's so many details that the planetary catastrophe guys have right. But you can't ignore the equal amount of evidence that, like in Hamlet's Mill, they talk about this precessional cycle that was traced not only for one full cycle, but they knew how one cycle varied and drifted off from another one. That tells you that for multiple precessional cycles, they were able to keep track of that, and that they were relatively the same. That, again, that would appear to be a conflict with the planetary catastrophe worldview, but it's not.
Yeah, I really like that idea of yours that, large scale cycles, if you consider them on a smaller scale, both spatially and temporally, they might look like catastrophes, right? Because you don't have a bigger picture. But when you have a bigger picture, you can basically allow small scale catastrophes, if you know what I mean. Mm-hmm.
Right. I mean, that's even what affects, like, the part that the mainstream had right with the Nemesis star cycle is that there could be radical catastrophes on Earth where like life is wiped out down to almost the cellular level and then comes up again. That was one idea put out, but that would still leave you with that nice cycle that they had of the time period that happens. And that cycle, that's the one that's the longer cycle than the Yuga cycle in India. It's the one that matches our motion around the center of the local chimney. And okay, I'm shut up now.
No, you're doing great, Jeff. Really good.
Yeah,
well, it is hard to go by, from the, like I say, I try to a lot of times give the impression that I try to stay focused on the more mundane part, and people wonder why I could spend so much time on how our solar system spirals through space. But what's always behind the scenes is I believe that worldview has to be put in place. But if you at least see how the solar system spirals around into and out of a magnetic field, that's enough for me to make that my part. And that's, again, the biggest problem isn't that all this research isn't out there. There's people that have spent their life on the Sirius Research Institute. He spent decades just observing where Sirius was each night, just night after night, going out and seeing how it moved compared to the day, like exactly when it crossed over his telescope, which was set up just on that object. All that stuff is out there, and unfortunately, it just has to be put together. There's so much in the CPAC community, those were the ones on the conference on precession and ancient knowledge. They did so much on these long-term cycles, and they had good, like, that's where Robert Schoch fit in there. He was trying to date the genome for dating the Sphinx to what would be the last peak in that cycle, and others are working on the calendar idea. And then you've got almost this detached from that EU community and the catastrophists that are on like a whole different track. But in a perfect world, that would have all grown up together.
Well, I actually feel like this kind of research might be a sort of a next level of EU-ness, if you know what I mean. Like, I was really amazed when I watched the Symbols of an Alien Sky for the first time, because it kind of put so many different things together. And I think this idea of but it was talking almost only about the solar system. But if we're talking about this larger scale phenomena, these Birkeland currents of more than interstellar scales, traversing the whole like clouds of matter 1,000 light years long, then it might truly bring a narrative that would unify many of these different theories. And this is really great, I think. I mean, this is like what thunderbolts did one time, but even bigger, Well, that might sound too arrogant or something, but that's what I really think. Yeah. So, okay, let us return to the solar system. So you've mentioned that this idea that we're traveling along a Birkeland current could explain the observational correlation between the inclinations and spin axes and things like that. Could you elaborate on that a bit more?
Yeah, well, the idea is that if there really are cylinders of charge coming down through the solar system, you might think that planets are just in them, but they can't be, because the orbits aren't completely circular. So they could either be right in the middle of one, and then their spin axis could be aligned with that cylinder. And that's what I think is happening with Venus. Venus is staying at a very constant radius from the sun, and its spin axis is aligned with orthogonal to its orbit. In other words, it could be feeding off current coming down through the solar system. But with planets like Earth and Mars, when Earth is farthest from the sun, that's when Earth's north pole is tilted towards the sun. And when Earth is, or there's a pretty close correlation anyhow. And in the winter in the northern hemisphere, when Earth's pole is tilted away from the sun, that is actually very close to perihelion point by within a week or two, and within 2 weeks anyhow. And so you get the idea that when Earth is closest to the sun, Earth's north pole is tilted outward. When it's farther, it's tilted inward. In other words, it's tilted towards a constant radius from the sun. That's how you make sense of it. In other words, if we're in a Birkeland current, the planet axes would be getting current from that cylinder and tilted towards that cylinder. So that's how I envision that working. Anyhow.
And well, I already asked you this question before, but what do you think in this context about the planets with very low eccentricity but high axial tilt, like Uranus and Neptune, for example?
Yeah, see, when you get out, that's where the whole well, that last link you sent me too about how the outer planets seem to be in a whole different set for their relationships. It was kind of talking about the same thing, like with as far as orbiting the center the center of mass, it's where the center of mass lies. Like effectively we're orbiting the sun, but when you get to the outer planets, they're orbiting the sun and Jupiter. You know, that would be the easier way to explain that. But yeah, the key, like when you look at the solar cycle and that motion around solar system barycenter, that makes perfect sense in the EU model. Once you realize how fast the magnetic field of that solar system filament changes direction. See, if that original model was right of the current with the magnetic field wrapped around it, then if you put the sun at the center of that and moved it outward or a little bit, it wouldn't really matter. But if you're talking about a magnetic field that starts changing direction right away with radius from the center, now you see why moving the sun back or forth a little bit off axis is going to make the effect that it has. And I think I still have to do more work on that, but you can see how that matches to what we see with when the solar cycle is active or not, and more importantly, what happens when charged material erupts from like solar arcades. You can explain that by the background magnetic field, and that was pretty much the key to insight in that is when you see solar arcades as they erupt and expand in radius, and then they twist, you have to ask why they do that. If charge is supposed to be spiraling around the background magnetic field, the only way to make sense of that is if the background magnetic field is twisting as it moves out, and that's what should happen. If the whole solar system is in a Bessel function filament with the sun near the center, then as something expands outward, it's going to have to twist because the background magnetic field twists. So the solar arcade spiraling around it will twist also. So in other words, you should see a different direction of spiraling with radius from the sun if it's the external Bessel function magnetic field that matters.
Well, that kind of makes sense. I mean, if the motion of barycenter is what governs the solar cycles, then it's not a big miracle that it almost coincides with orbital period of Jupiter, right? Because 11-year solar cycle, 11.8-year Jupiter orbit. If Jupiter kind of tugs the sun back and forth from the axis of this current, it would cause something like that, right?
Right. Yeah. To just go through the mainstream background on what their observations are. First, someone noticed that there seems to be a correlation between the solar cycle and Jupiter's orbit, and then that got someone working on the idea that actually it matches even closer if we add in the other planets. And then from there, like one thing I did is I looked at extreme solar cycles or extreme minimums, and sure enough, you find a correlation between where the outer planets are. Like, as you would expect, there are years where all the gas giant planets are strung out along one side of the solar system, which puts the sun way outside the barycenter. And then there's other times where you might have Jupiter on one side and then maybe Saturn and Neptune on the opposite side. And you can see this if you have astronomy software and a good record of the solar cycles over the last number of years, you can actually go back and forth. And I did that for a while, like put where are all the planets compared to the sun in like during the minimum or during these maximums. And then you see that pattern. Yep, absolutely. So in other words, every year you should get, as the sun orbits the solar system barycenter, or every 11 years, whatever, you might expect a solar cycle, but there's still greater and lesser ones depending where the outer planets are. The more pronounced ones when they're in the same part of the sky, and less when they're more balanced out, in other words.
So do you think minimums, like grand minimums like Maunder or Dalton minimum, do they happen when the planets are on the same side or on the opposite sides of the sun?
Well, you'll get that's where I notice it's that you have to use the next frame up yet too, and there's not much attention yet in the mainstream and putting that in where they are compared to the background stars, because what you'll find is that some of the peaks both ways have the same correlation, but just in the opposite direction of the sky compared to the background stars. In other words, you can't answer that alone by in other words, it's not just how the sun is moving compared to the planets, it's how it's moving compared to, if we are in a bigger filament, obviously, that's what you want to do, and that's more fixed even than the planetary orbits.
Well,
Again,
that kind of makes sense. Yeah.
Yeah, just even being open to that general picture. What you would have to believe is for it to make any sense of the sun's in an electric universe, say we all accept that part already, the only way to make sense of the barycenter idea with motion or the solar cycle is to accept the idea that the filament isn't by definition centered on the sun. The sun's axis isn't inherently part of that large scale filament. We know that the planets, obviously like Pluto, it's clear that that has to be moving in and out of that large scale filament. But you have to realize the sun does the same thing, just to a smaller degree. But you have to unplug the sun from the idea of being the center of the filament and know that that little wobble off center is going to cause a huge change then in background magnetic field direction, and then you've got problems, because as long as the sun is actually in the center of the filament, that's when you can match the differential rotation of the sun exactly to a minimum energy configuration of a Bessel function filament. In other words, faster, slow rotation near the poles because the center of the sun is traveling along the center of a filament. Way out at the equator, where the magnetic field starts to become wrapped around more, you have faster rotation. So that explains the differential rotation of the sun. But in that case, if the sun is at the center, you can match every point on its surface to the background magnetic field direction, and you should have a nice, quiet, differentially rotating sun. But as soon as you pull the sun off the axis of that filament, you're going to start to have a problem. There's no longer any way to get charge all flowing along the background magnetic field. Sometimes they'll even cross that, and then what that does is that if the sun is rotating in a magnetic field where the magnetic field is axial, then you get that by the right-hand rule that should make charge blast out of the surface there at that point, and you can understand the whole dynamic right there. And then when you see that the solar arcades erupting from the surface twist, then it just even makes more sense that, yep, that's the background magnetic field that's doing that. That's not the field of the sun itself.
Okay, let's talk about this differential rotation thing. So I can pretty much understand how, let's say, different layers of the sun being in the different on a different distance from the filament axis or the current axis might rotate at different speeds. But at the same time, the Don Scott's model says that Birkeland current should also have a counter-rotating coaxial cylinders, right? So
right.
Why don't we observe this on the sun?
Well, see, if the sun had going towards it a small scale filament with lots of back and forth counter rotation, that you would see at different latitudes here, you would see maybe rotation one direction or the other. But if the whole sun is in the middle of a giant Birkeland current where the magnetic field only goes from axial at the North Pole of the sun down to more, more azimuthal in the direction that it's rotating. Basically, you get faster and faster rotation. That's what should happen in other words, the first counter-rotating layer of that film is outside of the radius of the sun. You get faster and faster rotation, and then outside of that, you might expect the opposite rotation. So, and that's the difference between like what we see on the poles of planets where you see the counter rotation. That's a relatively small scale filament with many counter rotating layers. But it's important to know that that doesn't explain rotation at all. That doesn't explain the differential rotation, faster rotation at the equator. What that should do, like if the sun was in a small scale filament like that, you would see lots of counter rotation this way and that way, but that would cancel out any net rotation for the sun. So basically, sometimes you see both effects. Like in Jupiter, you see counter rotating layers, but you also see differential rotation faster at the equator than the poles. And in that chart of wind speeds that you showed me, you could see both effects superimposed. Like you can see this spike towards the equator of fast rotation, but you can also see this sinusoidal variation on top of that. So in other words, really simply, we have to have this counter-rotating Bessel function filament flowing to the poles of Jupiter to explain the counter-rotation. But we also have to realize Jupiter is in an even larger scale filament, and that's where the differential rotation comes from. That magnetic field has to rotate slowly over the whole radius of the planet, basically, to give you that differential rotation, where at the equator, where it's wider, it covers more of that change in magnetic field direction. You get faster rotation. But basically, you're seeing the signature of both scales of filaments on the surface added up at any one point. It's just the resultant of those two things.
Yeah, that actually makes sense. Yeah. I mean, we clearly see counter-directed wind speeds at different latitudes in Jupiter and Saturn and even Earth. I mean, speaking about, trade winds and westerlies and things like that.
Right.
I just had this very weird idea that maybe this moving back and forth of the sun with respect to the current actually is what causes the magnetic pole change, because every new solar cycle, the sun is at the opposite magnetic polarity with respect to the previous cycle, right? So like right now we're entering the solar cycle 25, where we have magnetic north at heliographic north, but previous cycle was the polarity was at the opposite, right? So maybe it's the Jupiter kind of tugging the sun into or close to the next layer, of this counter-rotating filament, so that the sun depolarizes into the opposite polarity. That's right. Just the idea I just had.
Yeah, that makes perfect sense, because the magnetic field has to change direction fairly radically to give you that differential rotation. You see that it's going from almost no rotation at the pole to very fast. Then it must fairly quickly be in the other axial direction. So yeah, you're moving the sun back and forth, side to side in a Birkeland current, so that it should see a changing background magnetic field direction. Yeah, that's the way I see it too.
Yeah, okay. And I've had a question from Richard. So speaking about the magnetic pole changes, how would this large-scale current affect Earth's magnetic field? Do you have any ideas about that?
Well, yeah, that's the part that's clearly missing in all the mainstream data, is that as you move away from the Earth, all you should be seeing is the magnetic field of the Earth, because our solar system it doesn't inherently have this counter-rotating magnetic field. But you know that even with the idea that current is flowing to the planet, you should know that some component has to be from that outward from the sun. So they're trying to explain everything with the internal dipole of the Earth, and that doesn't work, and it really doesn't work in like the outer planets and their moons. So, but that's all they have to work with, and that's what they're modeling, is just that dynamo, and then everything that we see outside of the Earth is all from that internal dynamo. But you know that that's wrong. You know that there has to be a magnetic field from this large-scale Birkeland current.
So as I understand it, it follows from this model that a significant change in orbit, let's say, would lead to a change in the magnetic field. Is that correct? Of the planet, I mean.
Right.
Like for example, if Earth suddenly changes its aphelion distance to, I don't know, 1.5 AU, its magnetic field should also change.
Yeah, there'd actually be there would be no way if we are in a Bessel function filament, there would be no way to get from even one orbit to another without having that effect, that complete reversal of magnetic field direction.
Okay, and I'm just curious. I don't know what your thoughts on this are, but what do you think about the moon and the Earth? What influence does the moon have on us in terms of this, larger scale picture?
That's one I haven't really considered enough, actually.
Yeah, because maybe I'm a long time proponent of the idea that the moon isn't actually our satellite, it's our quasi-satellite. And I cannot prove that because International Astronomical Union did not even give any definition for what is a satellite, but they gave a definition for quasi-satellite. So the moon fits. The problem is all the natural satellites of all the planets, they have their orbits aligned to the equator of their mother planet, so to speak. So, for example, the inclination of Titan with respect to Saturn never changes with respect to Saturn's equator. Well, at least, on the time scales that we are able to observe. But the moon's inclination is not bound to Earth's equator. It's actually bound to its orbit, so to the sun, basically. So the moon is, and another fact that Walt Thornhill, for example, noted once is that, but it's actually a very known fact, that the sun attracts the moon gravitationally more than 2 times stronger than the Earth, and this is the super unique case in the solar system. You wouldn't find any other satellite like that. Like all the other satellites, like again Titan, Ganymede, Phobos, Deimos, you name it, they are all attracted to their planets stronger than to the sun, but the moon is attracted to the sun stronger than to the Earth. And there are also other arguments like that, but I don't know, maybe you've had any ideas about this. I was just curious.
No, that's something to I'll be focused on that now.
Yeah, okay. So, well, okay, anyway, my view is that the moon is basically a dwarf planet that has a one-to-one orbital resonance with us, So it just moves on basically the same orbit, but its orbit around the Earth is kind of virtual, if you know what I mean. because it's not even concave in any points. It always is moving around the sun and not around the Earth. But okay, so when we're talking about this current, and this is, I remember your talk at the breakout room at the EU 2016, I guess, and I've had this kind of objection already back then, although now I see more and more evidence to support your idea of this large-scale filament, but still, I know there are doubts about it because, in particular, when we're talking about the currents and things like that, people would ask, well, where is the evidence for this current? We launch space probes. Why don't we see any, any currents basically picked by those space probes? Where are the particles or whatever? What should be observed in this case? In the solar system, I mean. What can you tell about this?
I don't know.
This is certainly one
No.
that Chris Reeve has brought up. I mean, just as far as the way that the mainstream shuts down even the general idea of Birkeland currents.
Yeah, we'll see the problem is if to the extent that charge is flowing in these cylinders, it's not the charge that we're even measuring in the. Well, you already see how you explain like the equatorial current sheet, right? That's what you get in the larger scale Bessel function filament. Any charge, even this whatever's just ionized by the sun, will flow radially in or out in the current sheet because of the radial, cylindrically symmetric radial electric field of the current filament. See, that's the problem even in the EU models, that they want to use the homopolar motor idea, and that's because there was nothing else to work with it at that time. There weren't models for the radial electric field of the filament itself. But what you can clearly see, like in the solar wind, is that, like charged material does flow out radially from the sun's surface. And then all of a sudden you end up with it forming into these current sheets. But that should tell you that, yes, the sun has a radial electric field close to it, but then what must dominate farther from the sun is the field of that large-scale filament itself, and that's how you get that radial current sheet. But yeah, the problem with detecting even the flow of charge. Obviously, we can't see it by means of Faraday rotation for the current flow. You can't see things like that. All you would be able to detect is the particle velocities. But there's just so many wrong fundamental assumptions when they detect that. Even here on Earth, the idea of if you were getting charged particles in, obviously if the Earth had any electric field, then they would have to allow for that, but they know that the Earth isn't charged. So whatever we see streaming into the Earth is just a function of the particle energies themselves. It's not anything to do with Earth's electric field, but right away you know that idea is wrong, and that if spacecraft are doing the same thing that electric comets do, for example, if they're really charging up and discharging as they move in and out of the solar system, they're not even a good reference for detecting the flow of charge. And that's really the hardest part of that, is that I don't know if there's even a good way. Like there are a lot of arguments over what we see with the solar wind, and I'm not sure that if we still have an objective way to detect that.
Yeah, I can reinforce that because I've been thinking about this a lot, and I think in one of our previous podcasts, I've already stated this idea that our laws of magnetism are basically derived from the laboratory experiments where we have a completely different conditions, right? So we can, first and foremost, we can isolate different elements of a circuit. And so we can kind of more or less understand what is going on in a, this linear approach that science more or less follows since, I don't know, 1600s or so. But when we're dealing with cosmic plasmas, there is really no isolation. They're everywhere, and everything is connected to everything. So how would our even Maxwell laws, how would they work in such a conditions? For example, if we have one space probe measuring something in some point, well, it obviously can only measure what is different to what this spacecraft itself has. I mean, you can only measure the electric potential of something like the solar wind, for example, if it differs from the electric potential of the spacecraft itself. But if spacecraft is sitting inside of this solar wind, can it really have a different electric potential? So maybe our whole approach of I don't know, dealing with these things, and maybe our whole notion of, for example, the scalar electric potential or vector potential is not even applicable in those conditions. Maybe we have to work on some other models that would be more fitted to that. And I'm not even convinced that we can derive such notions. But anyway, so my general point is that maybe we lack the very, thinking mechanisms to even grasp what is going on these larger scales. Like, it's easy kind of to measure the electric potential of an asteroid with respect to the spacecraft and things like that. But if you are sitting in this current, like a fish in a, I don't know, in an ocean, the fish would have the same velocity as the water has, whatever it does, the fish, I mean. So can it detect this motion of water? I have serious doubts about that.
I agree, personally. So what do you think for a first shot at that? I think that's a nice kind of, at least
But
we're almost going on 2 hours, but go ahead.
yeah, but how much time do we have still? Do we
Oh,
have like half an hour? Because
sure,
I
sure,
think
sure.
I think we can.
I have something I'm working on a project that I need to get out for actually this evening. So, but another half an hour is cool. So.
Yeah, because I think we're moving closer to the end because
Okay.
I'm already on 0.6 here. So, in one of our previous discussions, Jim, you said that the Barnard star seemed to kind of close in on us, right? This is the star that basically has I think, the highest proper motion across the sky. So it's first of all, it's very close to us, and secondly, moves more or less, perpendicular to where we are moving. So you've mentioned an idea that there might be some electric connection between us sometime in the future when we come closer. And actually, Alpha Centauri system is also closing in on us, although maybe a bit slower than Barnard star. So can you comment on that?
Right. Yeah, like Alpha Centauri, if you even look at it where it fits like in the local interstellar cloud images, you might put that on like traveling more or less with us, still slightly closing on us, but But Barnard's star is coming towards us very rapidly, but what's more interesting is that its motion across the sky says that it's closing in on us in more of the solar apex direction, as if we're more or less merging up. And that would tell me, when you see stars doing that, most of the stars that we see, like in the local interstellar cloud, have very similar relative velocities. But if we see stars doing that, should be a sign that maybe we're headed towards a pinch in the future. If you see a star coming at you like that way, merging in the direction that you're going, coming towards you and intercepting you on your path ahead, that would be a hint that maybe there's another current filament, then that we might be headed towards another pinch in the future with that. So what I'd like to see there is more stars in that stream to know if that's right or not.
Well, maybe there are, kind of brown dwarf types of objects. Maybe we would start sending stuff our way or something. I mean, would you expect some kind of catastrophes like rapid pole changes or orbit changes during our closest approach to Barnard's star or Alpha Centauri?
I'm not sure what would happen. Where you want to put that in the cycles of what happened in the past, like where you'd want to put a pinch in. I'm not really sure yet. I'd like to see where the record of the last one was, and I'm not sure.
Yeah, so speaking about the last one, there's a pretty popular idea in the astronomical community that it was reinforced by paper from some 4 years ago. So that there was this dim star called Schultz star approached the solar system some 70,000 years ago, and it came really close, like, I don't know, maybe 70,000 AU. So that's much closer than 1 light year, So have you heard anything about it? Do you have any ideas about this?
Yeah, I'm not really sure on what. See, the only problem with all the mainstream estimates for where things were, where things are going, are based on like the instantaneous velocities now, and then mapping those to they map them pretty much straight line paths, or like long-term paths around the center of the galaxy, unless it's part of a binary star system or so on. But if we are really spiraling around in 26,000 years, whatever, 24,000 years for the Yuga cycle, currently 25,770 at the rate that we seem to be spiraling right now, then that would mean our velocity has to change even in that time scale, and the idea then of plotting like long-term star motions based on their current velocity obviously are going to be more and more in error the farther we get away from those 10,000 year cycles. We'd be all that information would be lost, basically. I mean, gone. So a perfect example, if you look at that picture of the local interstellar cloud, the one that just shows them kind of gently curving, we know that right now the sun is skimming along on the surface of that cloud. That comes right out of the mainstream articles on it. But what they think is going to happen is that we're going to keep going on a straight line as the cloud curves away from us. Now, know that, nope, what's going to happen is we're going to keep curving along on that cloud too. But so the mainstream will make it just a coincidence that we're moving along the surface like that. So that's right away, though, you see that the problem for tracking stars over long periods of time. Again, the best way to do it is to really map out the filaments. If you accept that stars aren't just randomly moving through these clouds, but are traveling along them, then the best way to get a long-term path is just look at the actual cloud itself and not the instantaneous velocity of any stars on it. And that's really where a lot of what I was focused on doing. The big problem, of course, is you can't see the clouds directly, so they all depend on maps on. All you can see is whatever part of the cloud is on a sight line between you and another star, and then you can kind of make them. The more stars you have, the better you can make a three-dimensional map. But as you can see in all the mainstream images of the local interstellar cloud, it's still kind of a weak mapping still.
Yeah, because we can't see this plasma, right? It's in the dark.
Well, yeah, it's not just that, but even like the neutral gas and dust. The only way you can see that's with the local chimney. That's where you can see the hourglass shape. It's not by the charge that's moving through it. It's all that neutral material that's ejected to the outside. That's what made the mainstream aware of that shape, or why it's even a structure. They just see this hollow tube, but the tube is shaped by that like hourglass shaped shell of neutral gas and dust. Now we should also see even a dark mode filament in space should still have that, but on smaller scales, you're talking about obviously not then that kind of thick wall of gas and dust, but a thinner, like almost film of gas and dust. And the only way to detect that then is on any sight line to a star, you can see about how much is there, and you can still map that out, but it's just because of the scale of the local chimney, that feature of it, that the edge of the filament becomes really clearly defined, whereas in a smaller scale filament, you lose that aspect of it.
Okay, I have a kind of a small question and a larger one. So I kind of did not understand completely. Do we actually move along one of these Don Scott-esque type filaments, or we are moving in one of the filaments which is paired to some other filament and they kind of twisting together like this double helix nebula? This is a smaller question. And the bigger one, maybe, why do you always say there should be like two filaments? Maybe there should be 3 or 4 or 5. Like, how can we why is there only 2, or maybe there should be more?
Well, even in the double helix nebula, it's kind of interesting in itself. Like, is it really 2 or 3? But like, even in mainstream observation of this picture here, the local interstellar cloud, you see the way they have the local interstellar cloud and the G cloud, and from the mainstream data, they're 2 filamentary clouds that are kind of interacting. They're kind of shoved up almost against each other, and I would put those as probably the best mapping we have so far of a Birkeland pair. But the reason that we have to be spiraling around another filament is because of, again, just all the work that you've done with mapping those directions. Again, if our solar system, the part that Don Scott and Michael Claridge had, where we're just kind of traveling along on one filament face on, that's where you get all that stuff that should match up. The background magnetic field should be the same as the filament axis, and that should match the apex of the sun's way. The sun should be traveling along that. Other stars should be strung on that. We should be looking down their spin axes, all that. And since that's not what we see just the angle between our direction of travel and the background magnetic field direction should already be a hint that we're spiraling around the local interstellar field, which you do if you're in a pair of filaments. Then the solar system, the precession idea that our whole solar system is precessing makes sense. It doesn't if we're in a single filament, but it does if we're in that pair of spiraling filaments. The motion of Sirius again only makes sense if we're in spiraling filaments and it's spiraling around the same axis. And from that, you can actually get an estimate on the distance between the filaments too, and so on. But again, looking at the local interstellar cloud, if you want to match it to something on the same scale, the double helix nebula has that same 10,000 year spiraling. Ours is 24,000. The distance between the two filaments in the double helix nebula is supposed to be like 6 or 7 light years. And if you notice the stars here, like the sun to Alpha Centauri is on the order of 4-ish light years. So you're talking about the same order of magnitude as the distances between the filaments in the double helix nebula. So I'd have you look at them almost the same way, like Alpha Centauri and us on like opposite of the pairs of each on a different one in the pair of Birkeland currents, and then Sirius spiraling around on one of them behind us. So,
but still, I mean, I see this evidence supports the idea that there's more than one filament. But how can we distinguish whether there's 2 or 3 or more? Is there any clear evidence about that?
Well, that's where they're even still. I'm talking, mainstream estimates of what clouds there are and which ones are flowing together and interacting, and that's still. And as you can see, the issue, as I'm saying, like on the small scale, like this is relatively small scale in that all we have observational evidence for is how much gas and dust is between us and those local stars. Like we know how much gas and dust is between us and Alpha Centauri in that picture. We can get an idea of how much is between us and Sirius. And then outside of that, then all we know is how much gas and dust is between us and whatever far local star. So you already see how even in that picture, it's only weakly mapped out. I mean, just it's amazing that they even detected that these are filamentary clouds based on what observations they have to go with on that.
Okay, there's another question that I completely forgot about, but you've had this idea that cosmic microwave background might actually originate from this filament, or is that correct?
Yeah, that's not my idea. I'm trying to remember what I think it was. Walt Thornhill made me aware of that idea. I'm not sure the path he took to get there, but yeah, see, that's the whole point is that you do get from filaments, you should get microwaves just because you get microwaves, for example, wherever that hot excited gas meets those cold, dense walls of material. In other words, at the boundaries of every current filament, you should get those, and that explains the cosmic microwave background to the extent that it's uniform everywhere, is because there's filaments everywhere. But also to explain a dipole, then that doesn't make sense, except if it's from a filament that you're in, then obviously, you can explain the dipole, especially the fact that our solar system somehow is aligned with the dipole. See, that the whole idea is that since the mainstream found that our solar system seems to be aligned with the microwave background, that should be an idea that it's not a universal scale phenomenon that you're looking at. It's just that's a local effect. But again, since other filaments out there do show the same thing, you're still going to have that effect coming from every direction. But you have to map the dipole to a filament you're on. And now the problem is, and that's what that recent article I sent with where they see in space on the large scale, they see an element of the dipole that's aligned with the galaxies seem to be rotating on this axis, and the polarization measurements corkscrew around that, and polarization is measuring the magnetic field. So they see in space galaxies rotating on an axis and a magnetic field that's corkscrews around that axis. That's evidence for an even larger scale filament. But then the problem becomes sorting out which signature is from which scale, because they should do that on all scales. So then that's why when you look at the cosmic microwave background, they try to just make sense with like mathematical models where you have like dipole, multipole, you see quadrupole, octopoles. Like, in other words, they don't really know what's causing all these poles, and they try to make just a mathematical model of what's doing it. But what we really should see is that from any scale of filament that we're getting microwaves, we should see one aligned to the features that you would put with that scale of filament. Okay, I'm not explaining that well at all.
Well, it kind of makes sense. I mean, well, what they really mean when they say like quadrupole or octupole, are they, different types of symmetries that are observed in the, variations of this signal. So actually, maybe this might be the evidence for, the structuring of the filament itself. I mean, in this framework, if we believe that we're traveling along this filament. So it might actually be an instrument to map it someday, at least one of the instruments. But anyway.
Yeah, see, the problem we have is so much of that's dependent on that redshift idea and blue shift, and the problem with that is that we have to keep in mind, like Holt and Arp showed absolutely that redshift doesn't just come from Doppler shift, but it does come from Doppler shift too. It's just there must be another mechanism, and that's what's really the problem, is you don't always know when you're using the right choice. We know that there's Doppler shifts, like when one star orbits the other and we can see them orbiting each other, and then we get a blue shift of the one that's coming towards us and the red shift of the one that's going away. So we know that the Doppler shift idea works. But then we have these other red shifts, and that's where like plasma redshift idea. And then that makes it really hard unless you have a whole nother way to confirm which one you're seeing. You can't even separate the components then, which ones are real velocity ones and not. And See, I more than anyone would like to, in that case, accept the mainstream view, because the mainstream sees that where they saw that dipole aligned with the ecliptic, where one above the ecliptic plane and below the ecliptic plane there was that difference. If that really was velocity, as they think, that'd be great, because that would mean our solar system is traveling towards one of the ecliptic poles and away from the other, and that kind of fits with what we're saying. But I don't want to use that as evidence of that, because I'm not even sure that that whole idea is. Yeah, I mean that's basically wrong, and that's the issue we have with where you showed the solar apex direction. I'm still wondering how accurate that is, because that still comes from, they still use the cosmic dipole even to figure out local dynamics, like how we're moving. That's supposed to be the reference frame. They're convinced that the cosmic microwave background is fixed to the universe. So we can use that then as a tool to measure our velocity.
No, I actually don't think so. I think they use like distant quasars, like, or something like that.
Right, but they do the same thing with the actually, yeah, I can show you the paper on that, how they do it, and they say it's confirmed with the microwave dipole direction, but it's not. It's still the Doppler shift idea, effectively, and then that's what we gotta. I mean, there's still too many. The observations are there, but they still have to be careful with their interpretations with that as velocity.
Yeah, we actually didn't touch on that subject of what could be the reason for, blue shift or red shift. Can you maybe give a short comment about how, maybe plasma phenomena could cause that? Like, for example, this issue of flyby anomalies, or like pioneer anomalies, where people use Doppler shift.
Yeah, even to show you that there's got to be some correlation. Like, notice with the cosmic dipole one shows a symmetry with, across, or asymmetry across the or ecliptic plane. But with the flyby anomaly, that was the same thing. It shows one, in that case, that's associated with Earth's equatorial plane. But basically what's happening with the flyby anomaly is if a spacecraft comes in from the equator and leaves along one pole, we see a little bit of a blue shift. And if it comes in from the equator and leaves along the other pole, it's a little bit of a red shift. And they interpret that as like, somehow this spacecraft gets a little extra speed boost when it leaves towards one pole, and slows down a little bit when it leaves the other pole. But there's so many issues that could come up with that, and right away they're assuming that the whole red shift and blue shift is actual Doppler shift, which, even if it is, that leaves you to speculate, like, why should it do that? But then there's the idea that it's not even actual. In the plasma redshift idea, it's a function of electron velocity, and then that would be saying that the current upstream from Earth is different than the current downstream, which you should already suspect that would be true. But then we should have maybe that should also show up, and that would be in the same direction. So, but you see, the idea that plasma redshift is kind of a function of like free electron density should already be apparent, like what happens with quasar redshift, that there's like the mainstream knows that there's an ionization front in front of these quasars, okay? And what an ionization front is a double layer. They see it like a shock front where the electrons are driven out ahead of the protons. But what they're saying is it's basically an expanding double layer. And that's where we see the high redshift of the quasars, but we're looking at them then obviously through this huge amount of, ionized material and free electrons, and the plasma redshift theory says that then that would explain that redshift. So now I'm digressing again.
Yeah, well, I can certainly reinforce your thought about there's a different current density at poles of the Earth. Again, at one of the recent podcasts, EVU podcasts, I mentioned this ESA press release about the swarm mission. So they clearly state that the Birkeland current, again, what the mainstream calls Birkeland current, but that's like a special case of what we call a Birkeland current, that falls into the North Pole of Earth is stronger than the one that is falling into the South Pole. So there definitely should be some asymmetry, polar asymmetry around the Earth in plasma terms, But okay, so by the way, Neil, how much time do we have? Do you have to go soon? Or?
I'm actually glad you asked. I actually do have to go, but I have my friends here, and it's very happily able to shut down when you're done.
Yeah.
So it's no problem there.
I think
I might not even be. I might be back. I don't want to stop this. This is great. And
yeah, I think we have maybe 20 minutes or 15 or something like that.
And then it's
well, that depends. Maybe other people would have something to comment.
Or... and that exactly. I don't want to stop this because we can have because of course we're going to edit this part out, obviously, but we have the opportunity to add some character comment flavoring that are of other people's comments that. And then, of course, the highlight, of course, is your guys' portion of conversations regarding these questions and so forth. So, yeah, I think it'd be great. While it's fresh in our minds.
Yeah, okay. So...
in fact, I wish I was going to be there for that. But still.
Well, goodbye, I guess.
No, don't let me stop you guys. Don't have a great time. And like I said, I might be back because... we have ice pellets building up, and there's about 6 inches of them right now, and it's covering everything. And I'm trying to get at, and and I just shoveled out to the end of the driveway, and the plow came by, of course, and there's no one on the roads, and and given how slick this stuff is, I might forego it, but I'm willing to give it a little bit of a shot. So we'll see what happens. I don't want to kill myself, if you know what I mean. So
yeah, it's eclipse time, so. Take care. Yeah. Don't kill yourself. We need you.
Well, thank you for pointing that out there, Eugene. That's great to know. By the way, bad luck for you on the roads. Have a great time. Sorry. Anyway, great. And like I said, I might be back before you're even done. I'll know in 20 minutes. So keep talking, guys. I'll be right back.
Yeah, the eclipse starts in 6 hours or so.
Yeah.
Oh, my God. Okay.
So beware.
Yeah.
Foreboding. All right. But like I said, I'll know in 20 minutes. And so if I'm back before you end your talk, I'll be here to ask some questions and comment with everyone else. So if not, well, my friend will shut down whenever you're done. So.
Yeah, I got about 10 more minutes, and I'm gonna.
I got it recording, so we're good.
I got it here too. So.
Perfect, because that means the ones that are fucked up. I got the bing on, then great. All right, perfect. Keep going then. Love you all. I'll be back, or not. I don't know. I'll definitely talk to you later. Take care.
Okay, Jim. So I have a little bit of a provocative question, I guess. So are you aware of any observations that could not be explained with the filament hypothesis? I mean, that the solar system is traveling along the Birkeland current?
Outstanding problems that still have to be worked on. You mean in the electric model of solar system traveling on a filament? Let's see what.
Yeah, well, maybe you think that there are some points that require like attention, so to speak, or something like that.
Well, yeah, I think Juan mentioned that too. Like we were originally thinking that the planetary spacing came directly from the Bessel function model, but that should leave fairly uniform spacing, like we see in at the poles of planets. You see those nicely spaced counter-rotating rings, and that's what you expect in a Bessel function filament. But that leaves still two open questions. For example, on the solar system scale, you do have a rotation in one direction. We don't have planets going one way and then another radius going the other way, and it's the same all the way down through this, not just the planets, but in general moons around planets, and in general, there's exceptions, but in general rotation axes of planets, you get the same rotation. And the only even possible insight I have in that is that there is an asymmetry in the Bessel function model in that regard, in that see, if you think of just point size particles traveling along a Bessel field, they should be able to go in either spiral around either way. But once you give objects some diameter, you notice that's where the asymmetry shows up. For example, if in that model, as Don shows, if you're spiraling around the direction that planets are, then a planet should be rotating in the same direction there. But if you spiral in the opposite direction, planets would still have to rotate in the same direction they are now. It's just because of, as you move radial outward, the magnetic field twists in one direction. So when you get out to where it's helical in one way, moving out farther makes it more helical. But if you're spiraling helical in the opposite direction, moving out still makes it less helical in that direction. In other words, you almost have to draw it out to see what's happening. But there is a real asymmetry that I think leads to objects with some diameter rotating in one direction, whereas point-like objects could go in either direction equally easily.
Yeah, I could actually say that lots of small bodies, such as comets especially, and asteroids, some asteroids too, they orbit the sun in the opposite direction. So this might be some sort of secondary evidence, I guess, for this larger scale filament. But I don't know, to be honest. But anything else, maybe?
Well, yeah,
something you have problems with?
Well, again, that spacing, that their planets are not uniformly spaced. If you look at the sequence, we're talking about, like, maybe a Fibonacci sequence. You get that the fundamental difference then from, like, say, exponential is that it's based on everything that comes up if you want to make the orbits make any sense of that, you almost have to consider that everything is orbiting everything else that's inside that orbit to get that pattern.
Yeah, well, that actually is perfectly consistent with Newton's theorem and Gauss's law and things like that. So I don't see any problems with that, to be honest.
Right, but you just said it, Gauss. That's it. See, current filaments are Bessel Gaussian filaments, but that's two different aspects. And I think at first I was trying to put, and Don was doing this too, trying to make the Bessel function explain that spacing, and it doesn't. It's the Gaussian part of that gives you that spacing. So that's.
Yeah, well, you have to understand, I'm not asking in vain. I'm as a researcher, I'm looking for, where can I put my efforts in,
Yeah, well,
to help the research.
Yeah, like does that make sense? That really you could almost think of each. If planets are out in these cylinders, each cylinder is orbiting all the cylinders inside of it, not just one cylinder orbiting the central axis, the second one orbiting the second, but each one is orbiting everything inside there. I think that's the key to understanding it, but I'm still, that's more like insight, but no, I don't even know if that's right, but that's still the open issue, is to explain that spacing and why it increases at the rate it does, and that absolutely doesn't come just inherently from the Bessel function part of it. All the Bessel function does is tells us how fast. That's why we needed gravity, for example. I should go back to that. If the Bessel function alone just says how fast something has to spiral at that radius, but there's no reason we couldn't have there's no reason a planet shouldn't be out where the magnetic field is axial, and then it could be traveling parallel to the sun, right down alongside the sun. But that's not a gravity only orbit, obviously. So it's that subset of gravity only orbits to magnetic orbits, but that still leaves us with these fairly equivalent spacing. If you try to put them in the same terms, in the same math, like we usually talk about gravity only orbits in some terms, and then Bessel function orbits is like winding rate. But if you put Kepler's law into winding rates, like if you think the sun is traveling down the center of a filament, Kepler's law actually just tells us that the winding rate has to go down as we move out. That's what Kepler's law says. A planet close to the sun has to be spiraling around it really fast, and outer planets more slowly. So you would get a line that would give you a line that slowly rotates from, well, very azimuthal by the sun all the way to parallel way far from the sun. And it would be then where those two lines cross, that would give you gravity only orbits that are also magnetic orbits. But then it's still a subset of those that are the Bode's law one comes from. It's a subset of those, in other words.
Yeah, that actually kind of makes sense, and I like this reference to Fibonacci because, as you said, if you have each next planet orbiting like all the previous ones with the sun, this is basically almost like the definition of Fibonacci sequence, that each next number is equal to the sum of the previous two ones. But maybe it's a different series. Maybe it's not Fibonacci, but something else like that, So, yeah. But, okay, I'd like to kind of move to a more general discussion. Maybe you have any thoughts about the fractal nature of the universe. Like, there's this idea that everything, if at least like most of the things are organized with magnetism, and you probably know this plasma cosmology idea of this triple jump, this jump in scales from like laboratory plasmas to planetary magnetosphere plasmas to cosmological scale plasmas, where basically the same effects manifest more or less in the same way. So, and actually, I should add here that Edo and this group that is associated with him, we've had some conversations lately, and they made me aware that even maybe even the like subnuclear and nuclear particle physics could also be manifestations of electromagnetism. Actually, maybe there's no nuclear force and things like that. So maybe there's more or less the same type of organization present from the subnuclear particle physics to like the whole universe level of scale.
Right. That's where I saw that if you consider at the nuclear level that there's plasma, I mean, like double layers, it wouldn't be plasma at that scale because that's below the scale that we talk about as plasma. But if there were double layers, it would explain the weird forces in that in a double layer, the electric field is kind of backwards, but it's the first insight in a double layer, it's a short range, it's a finite range force in a double layer. Like if you're moving out from the sun, there's no inverse square electric field. That double layer it's a really strong force compared to the electric field outside the sun, but it only exists between that double layer. And as soon as you realize how that works, the analogy of that to the strong force that holds, in the nuclear level, we're talking about a short range, very strong force, and that's the same thing that you have in a double layer on the solar system scale. And again, it's around that at the sun's surface, right at what would be the nucleus of our solar system. We have that same arrangement of force and same. I think that's the way I would approach that idea, basically. I mean, you can draw like even from on the solar system scale. If you assume that the sun has an electric field at all, you can draw in the inverse square, how it would fall off from the sun. But in the double layer, it's not only way stronger, but it's backwards of that, and you can see the bizarre effect it has on on the charge. I think that's the key way to do that. But that would again be in the picture of. I was really hoping Juan would have his book out by now, because he's so focused on this idea of a universe that's not just infinite in size and duration, but infinite in scale. And from there, I took on the idea of, let's see what we can map of the atomic scale to the solar system scale. And I found that there's a huge, it doesn't say, I'm not saying that is what's happening, but that approach let me look at, scaling a nucleus to the electron orbitals as the same as scaling the sun's diameter to the heliosphere diameter, and then that gives you the right picture of like, you know, how, at least if you wanted to say things were the same on a scale, what you would put to what. You wouldn't make planets like electrons. It would be these layers, these shells of material that would be more like electrons. But then you notice that planetary nebula, which are shells, show all these same weird things as electron orbitals. Like we have nebula, I mean, we have shells around stars that are concentric spheres or expanding. We have ones that are more dipolar. And in other words, if you look at pictures of electron orbitals, you see that too matches more the nebulae and stuff like that. So it's, once you do that, though, I think you get, with that picture, I think that you can take that farther and look at then all the scales of things, like why you see but stars appear mostly in binaries, and what do we see with, you see like in a lot of diatomic molecules. I mean, it would be nice to see basically all the patterns show up if you want to make that analogy like almost exact. And that's one thing I'm toying with it. The evidence for that so far is I would say is weak, but it's been fascinating to me just how much alike they are. But then, yeah, even like with light, like the laser light, that got into that because when they found out that laser light and particle beams too travel as Bessel Gaussian filaments, I'm like, that's way too much coincidence that and then they use the same Bessel function idea for electron orbitals. The same math comes up that we're using on the solar system scale, and it's just okay.
That's the theme, I think. That's what's
Is
coming
that why?
through.
Yeah.
I
Right,
can
buddy?
actually
But I think,
can actually
go ahead.
reinforce the Bessel theme by saying that I did my thesis at the university in optics. Well, I've dealt with the nonlinear crystals, like their response to the infalling electromagnetic waves. But the other guy from my group did a thesis on the topic of tractor beams, optical tractor beams, the topic that is pretty popular now, I guess. So and he used Bessel type beams, this conical cylindrical type of laser or whatever optical beams to manipulate smaller particles. I mean, he didn't use that practically, but he developed a theory of how it can be done, basically. Yeah.
Yeah, well, what I found fascinating, though, is if you think of the implications for that, like our solar system travels, if it's right that it travels like along that Bessel function filament, the only reason that works, the only reason we have these orbitals, isn't because of forces between the planets and the sun. That's not that is gravity that works, but to get that Bessel beam, it's dependent on there being all these small scale particles flowing in that. So if we want to treat it the same at the lower scale for like particle beams to say that they travel that way, you're going to need an equivalently smaller scale medium in which to, I mean, that means that our subatomic particles are not even close to being the smallest scale. As a matter of fact, we would have to have something as small to those particles as our protons and electrons are to the sun and planets. I mean, that much smaller to make the analogy work right and to make that explainable in the same terms. So that's, but see, even in the mainstream model, that tells you how far off we are with this whole, okay, the universe created 5,000 years ago, led idea that we were stuck within the darkest part of time would give us like a maximum scale of structure. And then the Big Bang, they're still having problems with that idea now, in that even 16 billion years, if you push it that far, still doesn't give enough time for gravity to form the structures that we see on the scales we do. But all I'm getting at is that there seems to be larger and larger and larger and larger scale structures, sheets of galaxies, clusters and clumps of galaxies, walls of galaxies, and the idea you're stuck with, though, is you can either put yourself in a special place and say, wow, we live right down here at pretty close to the bottom scale of the universe, and it's like almost infinite upwards, or the only other choice is say that it is infinite in scale up and down. That's what I believe. If the universe is infinitely old, then there's no limit, even in a gravity-only universe. If the universe is infinite in direction and infinite in age, there is no largest scale structure that, there's no limit there. But again, I would leave it to, I've had a lot of conversations with Juan on that, but that's his baby, is
Juan would be great to
this
include.
infinite scale idea. But I share that belief, but for me it's more like just a belief that the universe is absolutely infinite in scale, that there's no limit to.
And this is I can say that this is the only view that is compatible with laws of physics. Maybe we got the laws of physics wrong. That's another topic. But if laws of physics are correct, then the universe should be infinite in both time and space. That is what in time at least. Maybe not in space, but okay. So Neil also sent this question that does our local chimney, or this Birkeland current that we're supposedly traveling along, does it have any similarities to other structures in space?
Well, like other chimneys
maybe we see other currents like that. Well, you already mentioned this double helix nebula, right? As I understand.
Yeah, well, they actually see more chimneys too, like in other galaxies, and they think maybe in our galaxy, on the other side of the galaxy, that's actually harder to see something across the galaxy through the plane of the galaxy than it is to see things in distant galaxies. But they see these same things, these chimneys, and again, it's always supernova remnants. That all these in our local chimney. When they see that happening, they see a star stream going down through the center, so they think that old stars in that stream went supernova, and blew out. The walls of that chimney are just like a shock wave going out. But they see these in other galaxies too, and that's where, though, that ring, that's what really makes that that's not what happened, is that ring of stars that's rotating around the chimney axis. When they first found it, that was still compatible with a shock wave being blown out, right? It's like across the chimney axis, there's this ring of stars. Well, that might have formed by a blast of gas going out. But
do you mean the Gould belt?
Right.
Uh-huh.
Right. Yeah, that's wrapped around the chimney, but it's rotating, and it's rotating around the chimney axis rather than in the galactic plane, and it's rotating backwards from the general rotation of the galaxy. So they were having all kinds of trouble. Just the fact that it's rotating means it has to be kind of bound, even though they did, much to their relief, find that it's kind of expanding. So that took a little bit of the problem away, but you still have to explain why it's rotating as a ring around that axis. It makes perfect sense in a in the EU model, because we're saying that's a plasma torus, of course there's flow around the plasma torus, but since the mainstream doesn't have enough gravitational mass at the center of that thing to explain how that's bound as a ring in the first place, there's no way to explain that rotation. But that's probably one of the most compelling pieces of evidence that that's a pinch, is that ring of hot blue stars all the way around that are rotating around that.
Yeah, and those are the famous dots between the Squatterman arms and legs, right?
Right. Yeah, that was
to kind of relate to the thunderbolts.
Yeah. That's easier to see in that other picture of the local chimney where it had that it actually showed those dots under the arms in it too.
Right.
But in that picture, I still love that they point to it's irony on, for them, but you see where it says Taurus in that picture. They're pointing to what we're saying is part of the plasma Taurus, right? They're like, oh, this is Taurus. Yeah. That's. But again, it just.
It's a Freudian.
That's it. Yeah, that's that whole other argument though, that all that was named by and originally that name the constellation was named after the Pleiades, which is actually the cluster in the center of the Taurus, and that was just one of the hints that, and one of the stars there is named the central sun, the early translation of it. So somebody had to know that was the center we were going around, have some ideas with a star named Electra there, and the thing called Taurus.
Yeah.
I mean, that's
and
a
then
lot
the
awful
roots
lot
of
of
these words.
coincidence.
Then it gets into the language, and then exactly. Fast. So I'm going to have to cut it, unfortunately, guys. But not bad for the first time trying this. I think it was certainly compelling from my standpoint.
You're disappearing.
I'm disappearing, and ultimately that means the recording goes off. So from my side.
I'm still recording.
Oh, I'm sorry. Okay, from my side at least. So.
I was gonna. We've went up the road, and it's gonna be hard, but I'm gonna give it a try. But I went out with my friend, and we just got back from shoveling.
Okay.
So
okay.
I figured I'd take 10 minutes to breathe or whatever, and talk for a bit with you guys since I'm here.
Okay. Very cool.
Yeah.
I mean, why not?
Okay.
But I'm signing off. I'm signing off for now. But great job, guys.
Yes.
Thanks
love
very
it.
much for joining us.
Goodbye.
Take care, Dave.
Okay. Bye.